students, welcome to the lecture on inverse trigonometric functions, and after the lecture we will be able to learn the following objectives. Define inverse trigonometric functions. Discuss the domains and ranges of inverse trigonometric functions. Describe the graphs of inverse trigonometry functions. Explain the properties of inverse trigonometric functions. Let us start with the introduction to the inverse trigonometric functions. A function that is a solution of the problem of finding an arc from a given value of its trigonometric function. The 6 inverse trigonometric functions correspond to the 6 trigonometric functions: arc sin x, the inverse sine of x; arc cos x, the inverse cosine of x; arc tan x, the inverse tangent of x; arc cot x, the inverse cotangent of x; arc sec x, the inverse secant of x; arc CSCx, the inverse cosine of x. As an example, according to these definitions, x is equal to arc sin A is any solution of the equation sin x is equal to A. That is, sin arc sin A is equal to A. The functions arc sin x and arc cos x are defined in the real domain for mod x less than equal to 1. The functions arc tan x and arc cot x are defined for all real x, and the functions arc sec x and arc CSCx are defined for the mod x more than equal to 1. The last two functions are rarely used. Since trigonometric functions of these functions are designated as arc sin x, arc cos x up to arc cosec x. Specifically, arc sin x is the branch of the function arc sin x, for which arc sin x is greater than equal to negative pi by 2 and is less than equal to pi by 2. Similarly, the functions arc cos x, arc tan x and arc cot x are determined respectively from the conditions arc cos x is greater than 0 and less than equal to pi, arc tan x is greater than negative pi by 2 and less than pi by 2, and arc cot x is greater than 0 and less than pi. The inverse trigonometric functions arc sin x can easily be expressed as shown on the screen. The well-known relations between the trigonometric functions yield relations between the inverse trigonometric functions. For example, the formula is shown on the screen. The derivatives of the inverse trigonometric functions have the form like as shown on the screen. The inverse trigonometric functions can be represented as power series. For further detail, the example is shown on the screen. These series converge on x is greater than equal to negative 1, answer less than equal to 1. The inverse trigonometric functions can be determined for arbitrary complex values of the independent variable, but the values of these functions will be real only for the values of the independent variable indicated above. Inverse trigonometric functions of a complex independent variable can be expressed by means of logarithmic function. For further details, the example is as shown on the screen.
Okay, so let's talk about the meaning of an inverse trigonometric function, and let's first consider the usual sine function, and then let's compare it to its inverse function, sine inverse of x. The idea here is that this x right here in the sine function is an angle. You take the sine of an angle, right? And so that means over here that the y is the angle. So the inverse trig functions, because these are inverses, the x and y switch places, the input and output switch places. So the input here is the output here. The idea is that the sine inverse always results in an angle, okay? And in fact, if you know, so we might write it more like this now. Y equals sine of theta. Well, that means that, this goes both ways. Sine inverse of the number y equals the angle theta, right? You can switch places here. If you take sine of theta, then you take sine inverse of y. And if theta here's the input for sine, then theta is the output of the sine inverse. Okay, so for example, I know that sine of pi over 3, if you look at your quadrants, pi over 3 is up here. The sine is the y coordinate, which is square root of 3 over 2. The sine of pi over 3 is square root of 3 over 2. So what that means over here is that sine inverse of this y coordinate, square root of 3 over 2, is the angle pi over 3. So see how this results in the angle, and over here this results in the y coordinate. Okay, so some basics about inverse trig functions. There is a little bit more to them, which you'll see in other videos. You have to be very careful about how you choose your values, but we'll do some very basic examples here. If I ask you something like, what is the tangent inverse of the number 1? What that means is, what angle results in a tangent value of 1, right? Because the result of this is an angle. There's a couple ways to do this, but just thinking through it, tangent is positive in the first quadrant, so tangent is 1 whenever the angle is pi over 4, because this would be positive square root of 2 over 2, this would be positive square root of 2 over 2. Here's the angle, opposite over adjacent would be 1. So in this case, tangent inverse of 1 equals pi over 4, the angle pi over 4 radians. You could say 45 degrees as well. Okay, if I ask you for cosine inverse of, I don't know, how about negative square root of 2 over 2, then that means what angle results in a cosine of that? Well, cosine is the x-coordinate, so that means the cosine is negative. We might be over here. And if the cosine is negative square root of 2 over 2, then this is a 45 degree angle here. So the angle we're working with is 3 pi over 4. Okay, so just to give you some quick ideas of what inverse trig functions mean, there's a lot more to them. You have to be very careful. For example, in this problem, cosine is negative square root of 2 over 2 down here as well, right? Because the x-coordinate's negative.
Let us understand definition to inverse trigonometric functions. The inverse sine function, denoted by sine inverse x or arcsin x, is defined to be the inverse of the restricted sin function as shown on the screen. The inverse cosine function, denoted by cos inverse x or arc cos x, is defined to be the inverse of the restricted cosine function. The inverse tangent function, denoted by tan inverse x or arc tan x, is defined to be the inverse of the restricted tangent function. The inverse cotangent function, denoted by cot inverse x or arc cot x, is defined to be the inverse of the restricted cotangent function. The inverse secant function, denoted by sec inverse x or arc sec x, is defined to be the inverse of the restricted secant function. The inverse cosecant function, denoted by cosec inverse x or arc CSX, is defined to be the inverse of the restricted cosecant function. Students, now we will talk about how to identify the domains and ranges of inverse trigonometry functions. A function that has an inverse has exactly one output belonging to the range for every input belonging to the domain and vice versa. To keep inverse trigonometric functions consistent with this definition, you have to designate ranges for them that will take care of all the possible input values and not have any duplication.
We're going to evaluate some simple trig inverse functions here, some easy ones anyway, ones that can be done without a calculator. here I've got the cosine inverse of the square root of 3 over 2. And a nice way to think of it, or a convenient way to think of it, is say, well, this is an angle. So call it an angle. Call it theta. You know, we're used to calling angles theta. So this is theta. And what do we know about theta? Well, if the argument is positive, then theta is in the first quadrant. And that's true for every one of these that you go to evaluate, whether it's cosine inverse, sine inverse, cosecant inverse, whatever. If the argument is positive, then theta has to be greater than or equal to 0 or less than or equal to pi over 2. Okay? So that's the first thing. What else do we know about theta? Well, that the cosine of theta equals root 3 over 2. And we know that the angle that's true, that makes that true, the cosine of theta equals the square root of 3 over 2. It's a common angle, and it is 60 degrees, right?
30.
30. Thank you. I'm worse than my students. 30 degrees. Or I could just call it theta equals the square pi over, well, it's been a long day, square root of pi over 6. There we go. So we found it, pi over 6. That wasn't too hard, right? So what did we do? The first thing we did is we said it's an angle. That's what an inverse function is. We'll call it theta. If the argument is positive inside the inverse function, then it's automatically an angle in the first quadrant. And we also know that cosine of theta will equal the argument. Let's go over here and take a look at the sine inverse of negative root 2 over 2. This is a little more complicated, and it's useful to know all the graphs of these trig inverse functions. For one thing, just as kind of an aside, here I've drawn the graph of the sine inverse. And from the graph, you can get 3 points right off the bat. The sine inverse of negative 1 is clearly negative pi over 2. The sine inverse of 0 is clearly 0. And the sine inverse of 1 is clearly pi over 2. You go up like this and over, and you get pi over 2. But we're interested actually in the sine inverse of the square root of 2 over 2. And so again, you think of this as being theta. So I'm going to call it theta. Now, if it were a positive argument, I could say, well, this is theta is in the first quadrant, but it's not positive. So I look at the graph and I take a negative number like the square root of 2 over 2 or somewhere out there. I go down like this, I go over like this, and I see that my theta is between negative pi over 2 and 0. So I put, let's see where I can put this here. Maybe I can erase this. Hold on. Get this out of the way. So my theta is greater than or equal to negative pi over 2 and less than or equal to 0. It's trapped between here and here. And I'm asking, so then the next thing I ask myself is the sine of what angle that is between negative pi over 2 and 0 gives you negative root 2 over 2. Well, the angle would be, the reference angle would be 45 degrees. Sine of 45 degrees gives you root 2 over 2, but this is an angle between negative pi over 2 and 0, and it's negative, so what it would have to be is negative pi over 2. Excuse me, negative pi over 4. Might be saying pi over, I hope I understand.
No, only that
Pi
time.
over 4, okay. Yeah, the sine of negative pi over 4 will give you negative root 2 over 2, and it is between negative pi over 2 and 0. I'm kind of sloshing through this, but you get the idea. Okay, let's go over to here. Here we're going to look at the cosine inverse of negative 1/2. And so it's helpful, again, to have a graph to understand how to graph these functions. I look at this graph, and the nice thing about the graph is, just as an aside, is that the cosine inverse of negative 1 is obviously pi. The cosine inverse of 0 is pi over 2. And the cosine inverse of 1 is 0. So you get 3 points for free if you know how to graph the cosine inverse. And it will also help us graph the cosine inverse of negative 1/2. So this is not a positive argument in here. So I call this theta. Its angle is called theta. And what do we know about theta? Well, let's see. It's trapped in some quadrant or other, right? Well, let's see what it is. If I put up like a negative 1/2 here, again, I just go up here and I see where my y value is. Well, here it is. It's trapped between pi over 2 and pi. So here it is. It's trapped in there. So we're looking for an angle whose cosine is negative 1/2. Well, in terms of common angles, we know that that is pi over 3. Got it right that time. It's pi over 3. But it's not pi over 3. It's in the next quadrant. It's between pi over, so it has to be 2 pi over 3. So theta equals, if you can get it up here, 2 pi over 3. Another important thing to remember is that these functions only deliver one answer, and they deliver, in this particular case, it can only deliver an answer from 0 to pi and in no other quadrants. So you have to be very, very careful. These are the evaluations your calculator will give you.
The output values of the inverse trig functions are all angles in either degrees or radians. In general, the output angles for the individual inverse functions are paired up as angles in quadrants first and second, or angles in quadrants first and fourth. The quadrants are selected this way for the inverse trig functions because the pairs are adjacent quadrants, allowing for both positive and negative entries. The notation for these inverse functions uses capital letters. Domain and range of inverse sine function. The domain for sine inverse x or arc sin x is from -1 to 1. In mathematical notation, the domain or input values, the x's, fit into the expression which is as shown on the screen. No matter what angle measure you put into the sine function, the output is restricted to these values. The range or output for sine inverse is x, all angles from -90 to 90 degrees or in radians. If the output is the angle theta, then you write these expressions as on the screen. Domain and range of inverse cosine function. The domain for cos inverse x or arc cos x is from -1 to 1, just like the inverse sine function. So the x or input values are as shown on the screen. The range for cos inverse x consists of all angles from 0 to 180 degrees or in radians 0 to pi. If the output is the angle theta, then you write these expressions as below. Domain and range of inverse tangent function. The domain for tan inverse x or arc tan x is all real numbers, numbers from -infinity to infinity. This is because the output of the tangent function, this function's inverse, includes all numbers without any bounds. The range or output of tan inverse x is angles between -90 and 90 degrees or is in radians. See on the screen. One important note is that the range does not include those beginning and ending angles. Domain and range of inverse cotangent function. The domain of cot inverse x or arc cot x is the same as that of the inverse tangent function. The domain includes all real numbers. The range, though, is different. It includes all angles between 0 and 180 degrees between 0 and pi. Domain and range of inverse secant function. The domain of sec inverse x or arc sec x consists of all the numbers from 1 on up plus all the numbers from -1 on down. Letting x be the input, you write this expression as given on the screen. In other words, the domain includes all the numbers from -infinity to infinity, except for numbers between -1 and 1. Domain and range of inverse cosecant function. The domain of CSC inverse x or arc CSC x is the same as that for the inverse secant function. All the numbers from 1 on up plus all the numbers from -1 on down. The range is different, though it includes all angles between -90 and 90 degrees except for 0 degrees or in radians as shown on the screen. Graphs of inverse trigonometry. Trigonometric functions are all periodic functions. Thus, the graphs of none of them pass the horizontal line test and so are not 1 to 1. This means none of them have an inverse unless the domain of each is restricted to make each of them 1 to 1. To graph the inverse of the sine function, remember the graph is a reflection over the line y is equal to x of the sine function. The domain is now the range and the range is now the domain. Because the domain is restricted, all positive values will yield a first quadrant angle and all negative values will yield a fourth quadrant angle. The domain of the inverse cosine function is minus 1, 1 and the range is 0, pi. That means a positive value will yield a first quadrant angle and a negative value will yield a second quadrant angle. The domain of the inverse tangent function is minus infinity to infinity and the range is minus pi by 2. Pi by 2, the inverse of the tangent function, will yield values in the first and fourth quadrants. The same process is used to find the inverse functions for the remaining trigonometric functions cotangent, secant and cosecant. Look at the screen for better understanding. Properties of inverse trigonometric functions. Look at the screen here, which shows the properties of inverse trigonometric functions. Now in the end, let us summarize what we have learnt in this lecture. A function that is a solution of the problem of finding an arc from a given value of its trigonometric function. The trigonometric functions are periodic. Their inverse functions are multiple valued. The inverse trigonometric functions can be represented as power series. These series converge for x is greater than equal to negative 1, answer less than equal to 1. A function that has an inverse has exactly one output belonging to the range for every input belonging to the domain and vice versa. Trigonometric functions are all periodic functions. Thus, the graphs of none of them pass the horizontal line test and so are not 1 to 1. The domain for sine 1x or arc sine x is from 1 to 1. The output values of the inverse trig functions are all angles in either degrees or radians